Section 6.5, Trigonometric Equations. A trigonometric equation is an equation that contains a trigonometric expression with a variable such as sin x. The values that satisfy that equation are called its solutions, and some equations will have no solution. To solve this trig equation, the first step is to isolate the function on one side. Before we can solve for x, we need to isolate the sine of x. So we begin by transposing the 3 sin x to the left side by changing its sign. We combine the 5 sin x minus 3 sin x. That gives us 2 sin x equals radical 3. Then we divide both sides by 2, and we have sin x equals radical 3 over 2. Now that we've isolated the sine of x, we can solve for x. To solve for x, we need to look for where the sine of x equals radical 3 over 2. That suggests we would look at our 30, 60, 90 right triangle. Since the sine is the opposite over the hypotenuse, and 60's opposite is radical 3, and the hypotenuse is 2, we get the sine of x equals radical 3 over 2 when x is 60. So 60 degrees is our answer. However, typically answers need to be in radians. So we can write that as pi over 3. Additionally, we are asked to find solutions on the interval from 0 to 2 pi. Notice the 0 is included and the 2 pi is just an endpoint. Sometimes we're asked to find all solutions. Let's take a look at what this means. Let's begin by finding the solutions on the interval 0 to 2 pi. That's one complete revolution, and we already found that pi over 3 is one solution, but now we need to look in the other 3 quadrants. Since our equation is sine of x equals radical 3 over 2, though it doesn't show it, we know that that's a positive radical 3 over 2. So we use our memory device. All students take calculus, and that tells us the quadrants where our trig functions are positive and where they're negative. For the sine of x, it's positive in quadrants 1 and 2, and it's negative in quadrants 3 and 4. So we will not be looking for any solutions in quadrants 3 and 4. We go to quadrant 2, and we take our reference angle of 60 degrees, and from 180, we have to back up into quadrant 2 by 60 degrees, and that puts us at 120. Note that it's common to think in degrees even when they want our answers in radians. You can do it either way. 180 minus 60 is 120, and then we would convert that 120 to 2 pi over 3. Or you can say pi radians minus pi over 3 radians. You get the common denominator, and that simplifies to 2 pi over 3. That's the second quadrant angle that satisfies our equation. We were asked to find the solutions on this interval, and the values that satisfy this equation are pi over 3 and 2 pi over 3. Now let's take a look at what this means graphically. At pi over 3, we have this point, and at 2 pi over 3, we have this point. These are the two values where the sine of x is at a height of radical 3 over 2, approximately between 0.8 and 0.9. And these are the only two solutions on the interval from 0 to 2 pi. But sometimes we're asked to find all the solutions. To do that, we're going to look at more of the sine wave. Here's more of our sine wave, and if we take our first solution of pi over 3, you'll notice that if we go the period of 2 pi in either direction, any multiple of times, we'll get a family of values. Same with 2 pi over 3, we can go 2 pi, the period, in either direction, any distance, to get another family of values. So we need a way of taking these two values and saying that we need the multiples of 2 pi in either direction. To do that, we'll add 2n pi, where n is an integer. Notice that when n is 0, we get our original angles, and when n is any other integer, we will get other values in the family of values. So these are all the solutions to this equation. For example 2, we want to solve this equation over the interval from 0 to 2 pi. Before we can solve for x, we need to isolate the cosine of x. So we'll take our equation, transpose the 3, and divide both sides by 4. This is the cosine squared of x, so we'll take the square root of both sides, and we get the cosine of x equals plus or minus the square root of 3/4. And we simplify that, we get plus or minus radical 3 over 2. Now that we isolated the cosine of x, we can solve for x. A cosine value of radical 3 over 2 suggests we'll go to our 30, 60, 90 right triangle, And since cosine is adjacent over hypotenuse, we'll look at 30 degrees because the adjacent is radical 3 over the hypotenuse of 2. This is a first quadrant solution, but we want to find the solutions in all 4 quadrants. Our solutions will be 30-degree reference angles into any of the 4 quadrants that have the correct sign. And typically we use the All Students Take Calculus memory device to think about sign. But for this problem, there's a plus or minus, so we'll actually have a solution in each of the 4 quadrants. The cosine is a positive radical 3 over 2 in the first quadrant, and also 30 degrees down into the 4th quadrant. The cosine is negative radical 3 over 2, 30 degrees up into the 2nd quadrant, and 30 degrees down into the 3rd quadrant. So our solution in this interval, pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Recall that even though it's sometimes helpful to think in degrees, we need to report our answers in radians. Example 3. Solve the equation over the interval from 0 to 2 pi. We begin by bringing the sine of x to the left side of the equation by transposing it, so it's a negative sine x. Then we'll factor out the sine of x. When we factor sine x out of sine x tan x, it leaves just the tangent. And when we factor the sine x out of the negative sine x, it leaves the negative 1. Recall that when a product equals 0, you set each of the factors equal to 0. So the sine x equals 0, and the tangent of x minus 1 equals 0. That one can be solved for the tan x, so we get tan x equals 1. And now that we've isolated the trig functions, we can solve for x. Let's start with sine x equals 0. Notice that we have to solve this over the interval from 0 to 2 pi. So we'll think about this diagram. The definition of sine is y over r, and for that fraction to equal 0, the numerator has to equal 0, and y is 0 when it's at a height of 0. So we get these two values, x equals 0 and x equals pi. If you think about the sine wave, recall that it's at a height of 0, at an angle of 0, at an angle of pi, and then it's back to 0 at 2 pi. You might wonder why we didn't include that, but if you look closely at our interval, it does not include the endpoint of 2 pi, so we don't include it. Next, we solve that tan x equals 1. A tangent value of 1 makes us think of the 45, 45, 90. The tangent of x is opposite over adjacent, so that gives us a value of 45 because the opposite is 1 and the adjacent is 1. And that's a value of x equals pi over 4 in radians. Of course, we have to look for solutions across the entire interval from 0 to 2 pi. And so we'll think about All Students Take Calculus to help us look for where the tangent is positive, because our tangent of x equals a positive 1. So that occurs in the first quadrant, and it'll also occur in the third quadrant. And those two values are pi over 4 and 5 pi over 4. The tangent's negative in the second and fourth quadrant, so there's no solutions in those quadrants. To summarize, we solved our equation by factoring. We set each factor equal to 0 and solved each of those equations for the trig function. We then found where the sine of x equals 0 and where the tangent of x equals 1 over the interval from 0 to 2 pi. So these are our solutions. We were asked to find solutions over the interval from 0 to 2 pi. Now let's find the answer if we were asked for all solutions. Example 4. Find all solutions of the equation sin x tan x equals sin x. Because this equation is the same as the one we solved in example 3, except that we want to find all solutions, we begin with the same method as we did before. That led us to the sin x equals 0 and the tan x equals 1, so we'll proceed from there. Let's begin with the sine of x equals 0. The solutions we found in the interval from 0 to 2 pi were 0 and pi. And so to find all solutions, we'll start with those. And from 0, we can land on more and more solutions by moving 2 pi in either direction. A full rotation in either direction will take us back to that family of solutions. To get multiples of 2 pi, we have n be integers. And it's the same for pi. If we add multiples of 2 pi, then we'll get all the family of values that are on 180 degrees. Now, It turns out that these two solutions can be simplified down into one solution because these two angles are evenly spaced around the circle. We can start at 0 and go half a circle around in either direction an infinite number of times to get all the solutions. 0 plus n pi is a way to write these two solutions as one expression. So that's our answer. For the tan x equals 1, we found these two solutions. So we'll start with those, and we can get a full family of solutions for each one by adding multiples of 2 pi by using the integer n. But again, these two can be simplified to one expression. We can start at pi over 4 and just add multiples of pi an infinite number of times. So that's our answer. Note that for tangent, you can always simplify to adding an n pi. Because sine and cosine have a period of 2 pi, those may or may not simplify down, but tangent has a period of pi, so you can always write your solutions with a multiple of n pi. So that's our solution. Example 5. Solve the equation tan x equals 3.1044 over the interval from 0 to 2 pi. The tangent of x is already isolated, so we're ready to find our angle by doing an inverse tangent. Be sure your calculator is in radian mode, and you get 1.2592. All students take calculus reminds us that we are going to be looking in the first and third quadrant because our tangent was a positive 3.1044, so we're not looking in quadrants 2 or 4. In quadrant 1, x equals the 1.2592, and in quadrant 3, we'll use that as a reference angle. So from pi, we want to add 1.2592. Be sure to use your calculator's pi button, not 3.14, because we want to have enough accuracy before we round. So that is the solution for this question. Example 6. Solve the equation sin x equals negative 0.2315 over the interval from 0 to 2 pi. Since our sin x is negative, we know that all students take calculus tells us the sign is positive in the first and second quadrant, so we'll be looking for answers in the third and fourth quadrant. To solve for x, we take the inverse sign, and that gives us an x value of negative 0.2336. Be careful that these values look very similar, so we need to keep them straight. Since we're looking for our values over the interval from 0 to 2 pi, we can't even have that negative angle, so we're going to have to use it as a reference angle. The sign is negative in quadrants 3 and 4. In quadrant 3, we're going to start with pi, and from pi we're going to add 0.2336 to go further into that third quadrant. When we add those together, we get 3.3752. For quadrant 4, we take our value of 2 pi, and then we have to subtract down into the fourth quadrant. So 2 pi minus the 0.2336, and we get about 6.0496. And those are our answers.